And here we go. It's Monday, I see. Not too many people here. So I will try to be very entertaining for you to not fall asleep. Today, you will see how an IoT framework could look like, and especially one where we can look inside. And you have the big chance to ask one of the creators what is going on here. But of course, you will also do a little bit research on your own. So I will talk about the services that in IoTEmpower are offered. So I think these are services you find in any integration IoT framework. I will explain the overall structure, so how it looks like, and also why you have this kind of weird folder with the nodes in there. So we'll discuss that. And talk about nodes themselves, talk about the compilation process, and if there is time, or at least I will have a little bit to dig into how you write your own driver for IoTEmpower if there's some hardware you want to include. And maybe we think a little bit about what is going on with multitasking under the hood. So you remember you have done this feature report. So we're still working on that one. So you have this list of things you want to see. Because I'm presenting now something that might be some new features, but still kind of make sure that the ones you initially picked are still there. So if while I'm presenting you find a feature which you say, in general IoT systems or IoT frameworks should have this feature, please edit. Finally, at the end of this lecture, we will kind of reflect on that together. And so I will ask you how many features you have checked off and how many in comparison what you have seen during the next lectures. So I want you, while we are working on this, to have the GitHub page open. There you can easily look at all the source code and stuff we are looking at together. It's on github.com, IoTEmpower, IoTEmpower. You probably already know the URL. So I will now do a little demonstration and kind of walk through what is there. And while I'm doing that, I want you to answer the following questions. So one is, how can you install IoTEmpower locally in a Linux environment? Where are the tools and scripts kind of that come with it? Where can you find the documentation? And what is the role of the different folders in lib node types? So you might also want to open that. I have uploaded the slides. You find them on ulno.net. Yep. So let's look at this URL. See which browser it opens. None. Okay. One more thing. Has anybody of you managed to get the integration part in Flogo running? Because I haven't. Yeah. Yes? Which node did you use? Or which kind of activity did you use? So I just managed to get MQTT to MQTT, but not the condition.
We made a log, and then we made 2 branches.
After the log?
Yes.
Okay, I tried the no-op. The no-op didn't work, and then, okay. Would you share your solution? That's great, because then we can finish this part. Very nice. And then you just made a conditional branch, and in one condition you say if the string, or you convert the string to a number, and then if the number is bigger than something, forward. And you have 2 MQTT outputs. Okay, I tried that too, but so which one did you delete?
We had one MQTT and the second one, but it didn't work with the branch. So we had to make a third one and delete the first one.
How did you figure that out?
Trial error.
Amazing. Please mention that, that you finally figured out how Flogo works. Good. I posted as you see here, I posted a question on the Flogo community forum as I'm currently teaching an IoT Introduction class, but as Flogo as an alternative to Node-RED using GitHub. I managed to forward the payload from one topic to the other. However, I would like to receive a number as string, for example, 32, and then if the number is bigger than a specific value, like 24 forward and on or and off. And tried multiple things but failed. But my students succeeded. Maybe we should post the solution and ask, is this the intended way to do that? Okay, let's see what they answer, and but it would be also nice if then everybody can at least get to the point where they see how Flogo works as an integrator. Okay, back to this, and let's open GitHub. IoTEmpower, IoTEmpower. I thought I had internet. Let's reconnect. Okay. So what do you see here? This is basically the overall project. So most of the things you can actually see while you go to GitHub. So one of the first things you see there is a doc folder, and you will guess that's actually the place where you find lots of the documentation. Depending on which device you run it, there are different entry nodes. As you see, there's an index pi, there's a general index doc, and you can even, as this is all done in restructured text, click yourself here through the documentation and look at this stuff. There's one thing in the documentation which is not easily accessible on the GitHub, which is here the node help, and these are all the devices you can actually connect. So like, for example, here, so you see some of them are links. So, and we have to, for example, go to the main one. And you see that's the same thing you see when you open the command list on the gateway. So you can also go here and search on GitHub for something, like you want to know how temperature works in this repository. And, oh no, once upon a time that worked. What? Because it should be definitely here. And I also mentioned temperature here. So I don't know why it doesn't index that one. Okay. Different ways to use that. So then you have a folder bin. And in bin, you see there are lots of scripts. So one interesting script, for example, might be deploy. There you see a lot of bash. Yeah. So this is actually the thing which in the end writes or flashes or serially flashes or over-the-air flashes the firmware. But so there are different tools here. You see also there's a tool which some of you have discovered. It's console serial, which is actually a tool that opens a little console like the serial monitor in Arduino. So if you are on the command line or on the Raspberry Pi and have something connected, you can open console serial to see the console over there. Then you see all the dongle stuff, for example, in here. Yeah? So you see there's a dongle adopt, there's a dongle daemon, there's a dongle display, dongle probe, dongle scan, and a dongle starter. Then there's some tools for installing software. And then you see there are all these MQTT tools in here. So there's the MQTT listen, MQTT log, MQTT send. So kind of these are just handy shortcuts, which in the end just call here. You see the Mosquito stuff, which you have probably done before. So it helps to kind of check it out, what is going on there. So there's a U help and a U menu. So uhelp is basically the command line version and lets you access all the things in the in the help, and so you can also use, instead of the web browser, use the help on the command line. Umenu is a shortcut for that thing. Why U? Because the thing was named Ulno IoT before I renamed it into IoTEmpower, so that's where the U has to do with my name. So what else do we have here? There's here also the preflash thing. There's a preflash Vemos. There's preflash nodemcu. So if you kind of think there should be a tool, maybe check it out. Another thing to mention is just the compile tool. It's basically just running the compile process without actually flashing something. So if you want to just check if everything is okay, you can just call compile. So you see also there are other things. There's access point, and then all these starter things here. There's cloud command starter, and where do we have other starters? We had a Node-RED starter. So these are all the things for running the services, which we will discuss in a second. So what else do we have here? We have examples. That's definitely something you should check out. But there's one a very interesting example, which is the running node test. It's not really a unit testing, but you can see always there for every device that has been developed, there is one little example in here. So for all the drivers, they are tested with this file. And so if you look at the current version, I was working yesterday on the MPU 9250. You see that's the only one that is enabled at the moment. So, but you can make a copy of that file and then probably find some of the features you want to enable and see a reference in there. So that helps. And then there's this magic lib folder. So the first thing here is actually an Arduino library to connect an Arduino with the ESP via I2C. I think we will probably do that in one of the next sessions. So that's basically kind of components which make up the system. But as said, we should take a look at node types together, because mainly the most firmware and development works there. So when you see lots of folders here, can you kind of map these folders to something? I mean, ESP you all have heard by now, I guess, yeah? Do you know what the ESP32 is? It's kind of the big brother of the ESP8266, which we were looking at. So, but you also see, you heard about the Espresso Lite, yeah? So we talked about coffee in my class. Yeah, and then you see here Vemos Day 1 Mini. So these are basically just all the different boards I support. So if you look at, for example, at the nodemcu in source, you see only one file. So most of the folders just differ in one file. And this is kind of a file I showed to a lot of you already, because it has the definition of, or it kind of tells you again, what is SCL and what is SDA. So I always look at that file because there's the hint in there where are the defaults for the I2C bus. Yeah, you also see that there's a flash button which is mapped to D3. There's the onboard LED which is mapped to D4. This is specific for nodemcu and the Vemos Day 1 Mini. But you see there are kind of links in there. Yeah, so there's a base link. So let's check out the others. So if we, for example, look at the generic, or let's trace that back. So we have the Vemos Day 1 Mini, and we have a base that points to nodemcu. So we go to nodemcu. And see there we have a base that points at ESP8266. And ESP86 has another base, but it has a lib folder in there. So you see we have PWM. You remember what PWM stands for? Pulse width modulation. And see there's actually some code here for pulse width modulation. And that has to do with that the ESP has a different way of doing pulse width modulation than the ESP8266 has a different way of doing pulse width modulation than the ESP32. Most of the code is the same for the both, but here is one difference. And see, and then there's ESP, and ESP is the base for both the ESP32 and the ESP8266. So, and if we go to ESP, finally, you find in the platform IONE, and you find source and lib. And see, that's where all the magic is actually happening with the source code. So, and if you look here, for example, at the main file, it's a little longer than what you usually do in the Arduino IDE, but you will see that we have actually a setup function in here. See, that's the same thing. And we have and we have a loop function. Yeah, very short. So why is that all so long? Because there's a lot of tricky stuff going on with multitasking. I don't know, some of you have installed PubSub client and they kind of crashes sometimes. And it has to do with the timings, and you have to be very careful that you give enough time to all the different components you have in the system. That's also why you don't have the setup and the loop actually exposed in the configuration file, in the setup CPP you are actually creating. So if you see, there is a setup CPP in here, and this setup is actually including a setup H. And that's kind of a trick I do, so your setup CPP will be renamed in a setup H, and they will be included right here. This is where your stuff comes in, what you write in this one function. Okay, apart from this, you see all the drivers here. Yeah, and I think I will go into this in a little more detail later. So do we have? So why do I have this kind of links? With this links with the base links, what concept or what design pattern do I realize with this? What does it remind you of? Yeah, so ESP is the base for ESP8266 and ESP32. Inheritance, exactly. So I'm kind of doing some very meta inheritance here. Yeah, not on class level, but basically on different source code level. So what is happening here is we're basically having a hierarchy of devices and how they are in terms of features dependent of each other. So it's an inheritance structure I have here, exactly, well seen. No, that's good. So that was the first part. Let's look at the actual services provided. Yeah, so I will now go to the services running. I will actually start the services. So there was one question we haven't answered. Sorry, forgot. How do you can install? Sorry. So how can we install? So there's actually in bin an IoT install, you see? And this is actually, as you see, it's welcome to the IoT installer and so on. But if you read the manual, it actually doesn't say that you should call that. You can call later IoT install if you want to do a refresh, or kind of you can call an IoT install clean if you want to start over with the install. But what you actually want to run for install is this run script. So this is if you start IoT, then this run script is executed. So instead of, and IoT is just usually a link, so I can show you. How can I make this bigger? Yeah. So you see, usually IoT, this, if you call IoT, it's doing this here. It sets the root of where the IoT thing is installed, and then it runs this run script. And the run script, if all the compilation and stuff hasn't, and all the dependency haven't downloaded, will ask you if it should install IoTEmpower. So if you want to install this on your local Linux environment or under Termux on your phone, then you can just clone IoTEmpower, go to the root folder of it, and run. Yeah, you just do a bash run. So I can also go to IoT and say bash run. That's the same as if I would have typed in IoT. Yeah. And here now I can do oh no, that's just IoT install. No, but as it's all installed, it doesn't do anything. So if you, I could do an IoT install clean, but then we have to wait 10 minutes until everything is re-downloaded, or maybe even longer here. So good. This is this. So let's continue. So the next thing, the services. So as I told you, we can run this stuff on the Raspberry Pi, but we can also run it in any Linux-like environment. I think last time we tested it even should run in the Windows Linux environment. So you don't even have to have a special virtual machine. You can use this internal WSDL. So what services does IoTEmpower consist of? And for this, I wanted to actually show you the stuff on the Pi. No, okay, I will start it here manually. What have you seen running on the Pi? What services are running? What have you used? Your Mosquito. Mosquito is a pretty essential, lightweight service. It's the MQTT service that is running on the Pi. So, you're right. We needed one point to start Mosquito. What else is running? So I can't do that directly, but I will. So this is actually the MQTT broker script that is running there, yeah? Or if you now you know, you can check what is MQTT broker doing. MQTT broker, IoT bin. You can see that starts actually just Mosquito in the end, yeah? So we want to, in a bit, start this MQTT broker thing, but there's another service, there's another service I have to start first, which service is also running on the Pi. Kind of the first thing you use. That's an access point. Yeah, so you actually, it provides a Wi-Fi for you. So, and this service so this service is not here, is access point, and let's quickly give you an idea what IoT bin access point is happening in there. There's a nifty tool which is called create AP, and create AP is a script which allows you to create an access point. It does a little bit more, which goes create AP, doesn't do everything, so I kind of mangle some of the IP tables in addition. But so basically, this is all trying to make sure that the name service resolution works well and that you have an access point running. So this does also run on my computer. You will now see, if you open your Wi-Fi scanner, that I just opened an access point. I needed to open that first because Mosquito listens on a Wi-Fi interface on this 192.168.12.1 to start the MQTT broker. So we have two services running. What else is going on? I use that also a lot. Flogo is not running on the Pi, but Node-RED, yeah. So do IoT and Node-RED, you start with the Node-RED starter. The Node-RED starter is just a while loop which restarts Node-RED when Node-RED crashes. So we have Node-RED running, good. What else is running? You've seen this kind of file interface when you go to the website and then you click on this and then you see the file. I don't know if that works actually on my computer, but this is the Cloud Commander. Okay, I don't have Cloud Commander installed on my computer, but this is also a script which installs this file manager. So Cloud Commander is running. What else is running? What else have you used? Your web server is running. So Nginx is running. Nginx is a web server which is configured on the Pi and is running there. What can you see in the web browser? Documentation and the links to the other things, yeah? So as you see, if you call IoT doc, it generates some documentation. And I think it's serve, I don't know. See, and if you start IoT doc serve, it starts a local web server where you can browse the documentation. So let's open the browser here. And see, you have seen that before. Yeah? So this way, you can even, if you install IoTEmpower locally, quickly have a nice browser view of it. So you can not only use the uhelp command line tool, but you can also just run a local web server and then look at that stuff. So lots of things come in one package. And there's one more service, which is more meta in terms of service, not running. And there are two more. What else is running? Something to talk to this guy, which is the dongle. Yeah, so there's a dongle daemon. Any idea what the dongle daemon might do? So it's kind of unhappy now. Mm-hmm. So if you looked at your own dongle, you see that there's some status information coming in there. And this is what it says here with answering info request. So now it actually shows even here that my access point is up and running and shows the SSID of it. And it also shows the load of my computer on the little display. And this is kind of due to this dongle daemon. So we have the dongle daemon running. This is one more type of service. which is kind of the main thing, kind of managing all the flashing and the deploying and so on. Yeah, so basically the compilation service, which is only run when we trigger it. But I think that is the other service that IoTEmpower supplies to you. But I think that's it. So these are the services running on there. Yeah, we have documentation service, we have file management service, we have a web browser, we have an access point, we have the MQTT broker, we have Node-RED, so the integration service, and then we have some kind of utilities and deploy services to actually get the firmware onto our nodes. Okay, so next thing. So you have seen kind of this this weird structure, how everything is in this IoT test folder, and they're kind of different nodes. You create new nodes in there. So imagine we have such a folder structure in there. So we have my house, and there's a main folder, my house. There's a subfolder in there where there's this living room, and in living room is LEDs 1 and LEDs 2, and there's a kitchen, there's toaster and coffee machine, and the toaster has, but the LEDs have a topic RGB strip, each of them, and the toaster has consumption and switch, and the coffee machine has a device, coffee left and milk left and switch, and each of them are specific devices in here. And then there is a main power, and the system.conf is at that position. Yeah, the system.conf is in my house, and then are these subfolder structure. So I now want you to figure out how do you communicate with this house here when it is deployed via MQTT. Yeah, so which topic needs to be called with what to switch on the coffee machine? Yeah, what do you have to send via MQTT to switch on the coffee machine? What do you have to call to set all lights in the living room to blue? And what do you have to call to turn the main power off? Yeah, and then think, what is the general rule here in IoTEmpower to form topics, depending on this folder structure? Then maybe you want to check out the system.conf. So when do we want to make changes in the system.conf? 5 minutes. Finally, something for you to do. You see the roots that I started in home automation and then went to Internet of Things, yeah? That's why so many examples are from the home. Good. How do we switch on the coffee machine? What has to be sent via MQTT where? Any takers?
The top is my house, then kitchen, / coffee machine, / switch, / set, and the message is on.
Good. Just one thing, the my house is not in there because the system.conf is in my house. Yeah, so it's without, if the system.conf would be one higher, the my house would be included in the topic. So if you had kind of a neighborhood and would do the whole neighborhood, then could be my house, my neighbor's house, and that stuff. Yeah, very good. Okay, what do we have to send to set all lights in the living room to blue? Somebody else. What?
Living room / LEDs 1 / RGB set blue. It's the same with RGB 2.
With LEDs too. Yeah, exactly. Yeah, RGB, so you have another subtopic RGB and set. You all have used the little LED with IoTEmpower, so it's kind of the same thing. It works for the light strip too. Cool, is it? Okay, and the main power. So somebody else here. You kind of getting there. The switch.
Main slash switch slash set.
Off. Good. So just to check, how do I check if there's still coffee in the coffee machine? Which topic do I have to subscribe to get notified about the amount of coffee? It's kitchen, coffee machine, coffee left. No further subtopic. There will be something like a distance. Yeah, so you see there is an ultrasonic distance sensor. Some of you have already used it. That actually works. Yeah, you can measure the amount of coffee if you manually mount one of the ultrasonic distance sensors on top of the coffee thing. It will measure how much coffee beans or coffee grounds are still left there. It's not a bad thing. You can also work with scales. Good. What is the general rule? How do we form topics? Oh, I know it's Monday, but I think it's pretty easy. So we walk through the path to the device, and we just each folder we pass here is one part of the topic, and to the next topic we put a slash. And then we have to walk also through the devices, and look what subtopics the devices have, and make our way until the subtopics and still append each of these subtopics to the topic. And then we have to know, because this can be defined, what values to actually send to the topics. Yeah, so we look where the system conf is located. Yeah, we start there. And so if we want to go to the toaster switch, we have to go to kitchen, toaster, switch, and then we need to know, switch has a set subtopic, and then set. Now this is why it is just maps a normal folder structure. So with this you can build any type of hierarchical system which have locations and sublocations. And so the sublocations can have sublocations again. That's why all the files are in a folder, because I thought that is a very easy transfer for us to make. There's no big hierarchy in a JSON file. We just have folders, and we reflect the devices we have in an IoT system with the folder structure. And that usually works well. So when and why do I would like to change the system.conf? Should we look at the system.conf? So if you are on GitHub, you see in lib system template. And there's the node template, and there's the system.conf. So when you see by default 3 things that are commented out here. So when would I like to change these things? Now when would I like in a system.conf to set a different SSID and a different password for the Wi-Fi access, and eventually even a different MQTT host? What could happen with the services? So at the moment, all the services are running on a Raspberry Pi, or here in my case, they're running on my computer. But do have all the IoT services run on the same computer? No. So if you do that stuff at home and you don't want to use my weird access point, if you want to use your own access point, you might want to specify these values. Or you go to a customer. So imagine you are doing IoTEmpower for 100 houses in Linz. Yeah? And as you still think IoTEmpower is a little difficult and normal persons can't use that, so you make a service out of this. So you say, if I want to reconfigure something in your house, I come to you. So you can have all these configurations on your computer, including the respective ways to access their networks. Or I have at home a server where all these where all these services run and where also all this folder structure is, but I usually don't want to do the deploy from my server. I want to do the deploy from my computer. So you can have actually several participants in an IoT system which can do the deploy when they are in the system. So this allows you to deploy things even if you are not on that system. Yeah, or if you say, oh, it's nice that Mr. Nobesrat gave us the Raspberry Pi, but it's kind of compiling really, really slow. So we would like to use the compiler on our own computer. You just install IoTEmpower on your own computer, and then you make in the system.conf, you make the configuration of the Raspberry Pi. You put the configuration of the Raspberry Pi. And with this, you can then remote deploy to that. Cool, isn't it? And that's why I want to change the system.conf. Let's move on. Good. So let's look at one node folder. There's some weird stuff with environment variables and so on going on here. So I want to kind of shed a little bit of light on that. So please, while I show you and explain you some things, try to kind of take away what are the steps that are actually executed when you call deploy in a node folder, yeah? Or not only in a node folder or in a room or location folder or even in the system folder. And you have already seen that there's kind of an adoption, there's a deploy, there's something to initialize. So how these things kind of go together. And so then we will also see that basically I prevented multiple deploys running at once. So why might I have restricted that? Why do I want only one deploy run at one time? So let's check it out. Let's go back to the GitHub. And now GitHub is here. And see what's happening in deploy. First, let's see. The first thing you usually do is to call adopt. Yeah. So let's see. Oh, you see, adopt is just a link, and it points to initialize. And so what does initialize do? Initialize is basically just calling deploy adopt. You see that? So basically, initialize is just a deploy, or adopt is just a deploy. Here. So let's check then deploy. What is deploy doing? See, it actually has a help. You see, deploy actually takes compile, adopt, and then serial, and takes a port, and also force. Yeah? And adopt takes kind of this kind of weird, so you can actually give something behind adopt. And you could now read all this stuff here, but so let's look from the technical point. So what does it do? It checks if we have a node.conf, yeah? And then you see if we have a node.conf, it kind of does this locking that only one process can actually work. And if not, it complains. So, but if we don't find a node.conf, see, we are trying to find the system.config. and then look at the current path, and then we iterate through all of the subpasses. And so don't be scared, this is bash scripting, it's kind of funky stuff, but basically the find finds all the nodeconf in subfolders, and then depending on the subfolders, it calls deploy in all these folders. You see it goes in all the subfolders from where we call it, and then runs another one deploy in there, so recursively. The interesting thing is you get actually a list here. So if any of the deploys fails, you have a list of the nodes failed, and then you can run a deploy again or kind of walk to the node and say why it actually fails. So, but if we call deploy alone, you see it logs the process and calls a deploy single in a race condition safe environment. So, and deploy single, what can deploy single do? So, deploy single first calls this node config thing. And that's kind of where the magic with the environment variables happens. Yeah? So let's check out what read node config does. So you see it reads the system config. So the first thing it does is actually it reads the system config. And then after this, so that you see the default board is the Vimos D1 Mini, and then it sources the node config. So it does the system config, so all the environment variables from there, and then it overrides the environment variables from what is in the node config. So you can actually, if you write in the node config a different access point, you could even have different access points for different nodes. You managed. Oh, second cup. And so let's check the system config, because that does some interesting stuff too. So it finds the system config and constructs, depending on going up, the topic for the node out of it. And then see it also reads the it reads the boot config, which is kind of the Raspberry Pi configuration with the Wi-Fi.txt. And then it reads an etc. IoTEmpower.conf. So there's another thing where you can define defaults. And then finally, in the end, it reads the system.conf here. But let's check quickly the IoTEmpower.conf. So you find that one in etc. And you can, there's just an example there, but if you go in there, you see basically all the things you can configure. And these are all the things you can override on a per node, or on a per system, or on your system where you are actually living on base. Yeah. So there are 3 points where we can rewrite that stuff. Actually, 4 points. There is a boot configuration. There's this configuration in etc. There is another configuration in system.conf. And then there is a node.conf. And in this order, they are read. And in this order, you can override these configurations. So that allows you to be very flexible from where you deploy what, which is connected to which access point or MQTT host. In general, you don't have to attach this, but if your system gets complex and spans multiple systems, with this method, you can fine-tune what connects to what. So why have I restricted that one single deploy can only be called once. It seems pretty obvious now, but it's the, yeah?
Because all the configs get overwritten for each node.
Nah, that's not the big issue actually. So there are two issues. One is if you have two deployment processes trying to write the same node, it's probably not what you want. Yeah, so because that is the final unit which I actually encapsulate. And there's one more thing happening which I skipped for you guys. Let's check that. It's in bin deploy. No, deploy single, sorry. Build. So see there's something here, it's called prepare build dir. And this build dir you have maybe seen when we go to so I'm now in the node 1 folder here, and you see that there's a build subfolder. And in this build subfolder, you have source and lib, and you might have seen this structure already. So this is actually the same thing what platformio needs. Yeah, so if you have a platformio project, it always has this structure. So that what this prepare build dir does, it makes a platformio project for that configuration you do. Yeah, so if you look at build and look at the source, there are a lot of links, do you see, which kind of point to other parts of the system. And this is kind of the mix-up of the base system, and all this kind of hierarchy is kind of resolved. So, but these are kind of static drivers in this. This is basically the source folder adapted to this platform you deploy. But you see it has a generated config file, and you see in there it puts your data so it can be included for the connection. So there's a topic in there, there's a host name in there, there's an MQTT server in there, eventually an MQTT user and password, and a so-called discovery prefix, which is something we might come to later too. And then there's a key in there. We need this key for deployment. So only if you have this key, you can do the deployment. So, and the key is actually generated here when you do the first deploy in there. It generates a unique key. And only if you use this key, you can actually redeploy the node. Else you have to adopt it and put a new key on it. So what else is in source? And see the Wi-Fi config. Yeah. So now you know how to connect to my local Wi-Fi. And this is how it gets all the how it gets all the passwords and stuff automatically. In this pre-build, it generates all this information for you, and then I can just use platformio and compile it in here. The cool thing is also if I want to debug stuff, I can also just go to platformio and open just this folder in Visual Studio Code. So let's open Visual Studio Code. You actually have to give it the board as an environment name, else it compiles too much. So we call Visual Studio Code. And I'm now in one of these build folders. And you see here that it shows the stuff, and now you can just use the normal compile and build stuff in platformio, and also write your devices from there. That really helps when you kind of develop a new driver, which is part and part of this lecture. And see, in there it says setup.h, not a setup.cpp. But this is, see, I was working yesterday on the running node test, so I can be here, and then you can jump through your project and check how things are defined and use all the stuff from platformio to navigate easier and understand what is going on. Good. So we have that connection. Let's move on. Sorry, it gets even deeper now, yeah? So you have maybe seen that IoTEmpower, at least the firmware part, is pretty C++ based, but still very object-oriented. And one of the core classes in there is the device class. What does device stand for? You remember? Devices are the things which are connected to the nodes. The nodes are things like the Wemos D1 Mini or the ESP32 or so on. So everything in IoTEmpower, which is kind of hardware, is a device. Or is a sensor. A device is usually a sensor or an actor or a mix of it. So while I show you the device, I want you to pay attention to what are the common functions that devices support. So all of the things you define, so far you have only done always one line per device without any special. Some of you have used this with precision or with I2C, so some of you have seen that you can actually do things to the devices you define, yeah? So I want you to pay attention, what are these kind of generic things or the functions you can do on every device. I will explain you what the fluent interface is, but you can also Google it while we are working on it. So when you will also see what are normal methods and what are methods that you can overwrite, which has to do with when we want to build our own driver, we have to actually overwrite some of this when we inherit from device. And you will see what parts of the device are called in which order. And then we want to also know what are sub-devices. And then I will show you quickly filters. And you should kind of think there are some filters already defined, but maybe you have some ideas for filters we should define in general for later. And then you tell me. I'll write it down. So let's check out device, yeah? Let's go to GitHub. And where do I find the code for device? You know that already? In lib. Yeah, so you go to lib, and then I go to my node types. Where do you think the device code is? In which of the platforms? It's generic, so it should be an ESP. And so let's check the header file of device. So the first thing we see is a sub-device, but I think we want to actually check device. And let's check the methods device has. It has the constructor, so you can see a device always gets a name that you already know. And you see you can actually give it a poll rate. Any idea what poll rate could mean? It's similar. And it's more like the poll rate is how often does actually physical interaction with the respective hardware of this device happens. Yeah, so how often are some of these functions, methods which are defined below, called later? Because we have cooperative multitasking, and that's why we have to work so much with timing here to make sure that things are called often enough. So you see, devices seem to have sub-devices, so we can get something about that. You've seen that most things in IoTEmpower and MQTT are dealt in strings. Yeah? So this is why we usually ignore case. But if you want to write something to a display, you might want to have a differentiate if you do capital or small spelling. Okay, so you see there are some kind of on-change callbacks. And then you see you can set the poll rate, change the poll rate. So it's basically how often you are interested in a value from that device. And so you can do that on microsecond base, but usually you will just use it without microseconds, and then you can give them milliseconds. So on every device you can change a poll rate. So have you ever seen some kind of construction? You see these functions all return a reference to a device. I think that's something, I don't know if you can, yeah, I think in Java it looks the same, doesn't it? So you can do that in Java too. So why would I do that? So let's look at the main one here. So why would I do that I return the device? What allows me that to do? So imagine, let's go here let's go to the Visual Studio Code. So let's look at setup. Do I have poll rate here? Yeah, so I have a device, I2C socket, which has poll rate. So if I define, so that, this is a device. Yeah, so that returns an object, or defines actually an object. It defines an object of the type I2C socket with the name Arduino 1. And now I set poll rate here. So what does poll rate return? A device. So the cool thing is I can continue here and set other things. So I can do, for example, a with on-change callback. So I can call other methods now which are defined in the device. And then I can chain these. And this is called the fluent device. It's an interesting object-oriented design pattern or programming pattern to write or to give properties to objects. So you define the object, and then you attach and set all the properties of the object with the fluent device. Yeah, so everything is designed in this fluent way here in IoTEmpower. That makes the programming easier and easier to read. What was next? Okay, let's continue checking what is in here. And so poll rate we looked at. And then we can set an on-change callback. So you can actually give each device a function which is called when a change is happening. So very interesting if you, for example, want when you press a button to directly call a switch. So let's look back at the example here. So you know already how to do a button with input. See, so this input has a threshold and it has a callback. And so if we define here the output like this, then I can, in the callback, work on the button. see when the button is pressed, I can toggle directly the switch on the same device. So with the callback, I can do some of the things I've done before in Arduino with kind of big if constructions and so on. And with this, I can kind of call a function when a change happens. And this here is just the lambda way of giving functions in C. Yeah, so usually you want to do it like this, but you can also define a function before which is then called. So you can actually see yeah, later we will see a thing for calling just function also directly. So you can, instead of giving the closure here or the lambda construction, you can also call write this function directly. So let's go back. So then we have, this is all the same. Then we have a filter. So we can do a filter callback. Where would a filter make sense? Imagine some analog thing where you read kind of maybe a heart rate or so, and which actually just measures some current or kind of reflection on your skin, and then you probably will get a lot of noise, and you're not interested in all the noise. And you can filter out the noise, you can make an average about something. That's where you want to use filters. So let's look at an example of a filter. So you see here basically the example of an average filter. See, so I define a new analog device. Oh, it's actually the old way of defining it, so let's just do it like this. And then you see, yeah, you define here the things and you access then from there. But so you have also some default filters, and the default filter you can just attach with the macro. See, so this is basically doing the same thing as we have seen before. So if you often want to do that you kind of average about a lot of values you receive to reduce the amount, but still have the full scope of the devices you can measure. So we have filters we can attach to all devices. We look at the sub-devices later. So then you see all these things which kind of measure and poll measure and check changes and so on. And you see a measure init and a measure exit. So basically, during the process of a device, when a device is running, it's first started, and then after it is started, it always calls measure in the poll rate you have specified. And measure starts with a measure init and measure exit, and you see you can override these functions. So basically, something in the hardware has to be prepared before the measure, the actual access to the hardware is happening. So if I write a new devices, I have to implement measure init, measure exit. I have to implement start, which is kind of when the device first starts called. And of course, I have to implement measure. And measure has to return true when it successfully measured a value, else it will return false. So these are the things I want to implement. So let's kind of take a look at a device so you get an idea why we implement these things. So let's check out output. So see, output device, so basically kind of that you can turn an LED on and off or a relay on and off, inherits from device. And then it has this constructor, which, yeah, lets you define a high command and a low command. And See, it has an invert function. So basically, you can define in a Fluent interface that the device is inverted. But interesting now is where we implement and override the measure function. No, because we don't, toggle doesn't return any values. Sorry, let's look at an input. No, okay, but let's start with the output and I show you the sub-devices at least. So, the output constructor adds two devices. You see, one directly, empty topic, and one with the set topic. And when the set topic is called, it actually calls it internal set method. This is where we are actually doing the switch. So if you send something to the topic, subtopic set, you get it here as a payload, and then you can do something based on this payload. So let's look at input. And now input here. So an input we do override, hopefully, yeah. See, in input we do override measure. And see, that's what it does. It has a debouncer built in, and basically, finally in measure, we see, we read here this digital pin. This is where the actual physical access happens. And then we just write, so this is a string, and we basically, depending on if we are inverted or not, we read from there. Here we write actually into the measured value what we have read from the pin. So in principle, it's relatively straightforward how to get from the physical, what you actually get physically, to then the value. But the main thing, you usually have to override the measured value, and you have to define the right sub-devices in the beginning if you want to write a new device. Good. Think about what other filters we could use. I guess we don't have enough time to show you the whole driver. I think I will go to the IoTEmpower recap. So we'll do the driver next time. Do you guys want to see so I've built the new MPU 9250 driver, which is a gyroscope. But it's relatively complex. It has a lot of things in there. I could also build with you the MPR 121 or PCF 8591. MPR 121 is a capacitive touch driver. So you can actually touch 12 connectors, and you will see if you have your finger on there or not. You have any opinion? You want to do gyroscope or touch? No opinion. Okay, I will decide what's easier for me. Good. So look at your features. Yeah, look at your features of IoTEmpower. Look at the features you want to see in an IoT framework. So you have now seen one IoT framework, and you got some very theoretical walkthrough to all its features. How many of them have you checked off for IoTEmpower? So I want you now to compute how much percentage of the features you have checked off. So if the features you have set yourself in the beginning when we talked about IoT systems. So I want just to do a little hand count. How much percentage of the features does actually IoTEmpower cover? And maybe if If we get a really bad result here, I will ask you some of the features you are missing. Yeah, so compute the percentage of how many of the features you want to see in IoT framework we have checked off here. Yeah, look at your list you made and see how many features are present in IoTEmpower and make a percentage value of it. Put this number in your research report, but also let's do a little hand count on it and see if I successfully implemented something here or if not. And if not, you kind of tell me what else is missing. So 2 minutes to compute. While you compute, I kind of say little things about the lab, because lab today is easy. You start working on project 1, and the only new thing you learn is a scale. Yeah, try to make the scale run. I don't have enough scales. I think I have 10, so it's 1 per big team. You have to share the scale a little bit. But so let's quickly do the computation. You have the percentage. You can also estimate it. If half of it is covered, I have managed 50%. So for whom have I covered all features, 100%? For whom does IoTEmpower cover 100% of the features they want to see in an IoT framework? Nobody. 70%. That's cool. 1. 50%. Okay. Yeah, that 70% is okay. You can also, if you're 70%, you could still raise your hand. 30%. Or 25%. 10%. None. Some of you have not made the computation. So please do it at least for the research report. And so 1 or 2 features you still want to see, which you think I haven't covered. Then I let you go. What's missing? Nobody has 100%. What do you want to see?
Bluetooth support.
Good? Yeah, me too. So lots of people are coughing. Can you repeat?
A nice dashboard which has an overview of all incoming measurements.
We can do that with Node-RED. Yeah, but this part, it's one of the services which is integrated. So I think, yeah, but maybe a better manual for how to do that. Good? Mm-hmm. Anything else missing?
Field communication is missing.
No. We have that. It's at least in a simple way. So I do support some RFID chips, and you will get them next week. Next week you get RFID. Promise. Okay, great. Thanks, guys. Let's go to the lab and let's measure some liquids. And sorry, the driver comes tomorrow.